Okay. Kaushika?
Yes, sir, you can start.
Yes, sir. Yes, sir. Good morning. Start, sir.
Good morning.
Please, sir.
Okay.
Good morning. Namaste.
A very good morning to all of you. It's nice and sunny morning today in Mumbai. I don't know how the climate is in the other places. Well, today I'm going to speak to you on 7 correct steps for concrete making. Now, this is a lecture which was originally prepared for the concrete mix design workshops in Mumbai, which we conducted. So it reminds me of 2 events prior to starting the workshop. One was that we had received a request from late Mr. Amin, who was the director in Sapoji Palanji, and he requested me to conduct the concrete mix design workshop for his company. So the first workshop was conducted, but it was very sad that he could not make it, and very shortly he expired. Another memory comes to my mind is meeting my guru, Mr. A.P. Remedios, way back in the early 71 when he conducted a workshop for us and taught the Tata Electric Company's engineers the concept of concrete mix design. And it so happened that concrete mix design and my initials are identical. So many times my friends call me CMD, concrete mix design. With this, I start today's lecture. Now you can hear me, I think. Initially, when we got the first experience of concrete, I noticed that most of the engineers were very keen to get the desired strength. But very seldom the engineers paid attention to concrete durability. Very soon we realized that concrete durability is more important than concrete strength. Because if you get correct concrete durability, means you get the concrete strength also throughout the life of concrete. So I'm going to start on what makes concrete durable. The first is proper architectural and structural design. Very, very important. These are the genes passed on by the architect and the structural designer to concrete. The next step comes is proper selection of materials and concrete mix design. The third important aspect is proper construction practices, which is so very, very neglected in our country. Whether we do with modern equipments, whether we do with ready-mix concrete, or whether we do manually, the practices are very shabby and needs to be improved. So I will be explaining on every step of concrete making, what is to be done, how it is to be supervised, etc. And later on, when the structure is ready, we need proper maintenance and care so that concrete becomes durable. And just like a human being, as we age along, we get into problems of health, etc. And we have to maintain it by taking proper medication. The concrete also needs proper care and maintenance, or in other words, you can say medications from the civil engineers and the designers. I give you a very simple analogy. I'm sure most of you are married and some of you are thinking of marriage. Now, as for the Hindu culture, we take 7 pledges around the holy fire. And concrete also is produced in 7 steps. I will explain to you the Saptapadi of or the 7 pledges of concrete. I have lit the fire now. The first step is batching, where we make either manual or at site or using RMC. The next step is mixing the concrete. Once you have batched the materials properly, you mix the concrete materials in a mixer or in an RMC plant. The third step is transportation. Whatever concrete you have produced, it has to be transported to the formwork. That is also done using RMC and sometimes if you are doing manual at site. The fourth step which is required to be taken is placing the concrete. Mind you, placing seems to be the simplest step, but it is actually most complicated. One has to supervise the placing properly in order to ensure that the concrete materials, when being put into the formwork, do not segregate. By segregation, I mean the coarse part of the concrete, the aggregates should not separate out from the mortar. Now, this is a very, very important aspect. So those who are supervising concrete at the site must be very careful that the concrete does not segregate. So after mixing, while transporting also, sometimes the concrete segregates. And while placing, if we are not careful, it will further segregate. The fifth step we take is compaction. Now, concrete, whether you like it or not, brings along with it air. And air creates voids in concrete. So one must compact the concrete properly using a needle vibrator and ensure that concrete, whatever you put in the formwork, gets densified. The next step is finish the concrete. Finish by mean troweling the concrete and leveling it properly so that it looks beautiful, it does the job, and it also gives durability. Both. Now, when you take RMC at the site, the first 4 steps, you completely rely on the equipment and the manpower of the ready mix concrete. The 5th and the 6th step, which we take, we have to supervise properly at the site, because that does not come directly under the scope of the ready-mix concrete. And the last step is curing. Now, curing is extremely important. I don't have to emphasize it over and over again, because curing done well also gives you the advantage of durability, makes the concrete stronger at the surface, so it does not allow any chemicals, any water to ingress into your concrete. And whatever efforts you have made in the mix design and whatever efforts you have made on the site for conducting all the steps of concrete making can get spoiled, and you may not get the desired durability. So this is a very, very important step in concrete making, though it is the last step. So if you take these 7 steps carefully, your marriage is confirmed as per the Hindu culture. And in concrete making, I give the compliments to engineer and concrete for a successful married life. Now, what does this Saptapadi mean? When you get married, you give all sorts of promises to each other, but I have noticed that sometimes when the fire is put off, the fire in our heart also vanishes. The first promise you give to each other is to gain livelihood. The next promise you have given is strength, physical, mental, and spiritual to each other. The third promise you make is gain wealth and prosperity so that you remain comfortable in married life. The next promise you make is knowledge, harmony, and happiness to each other. Healthy, long-lived children, you promise each other. And the joy for all seasons. If you finish your concrete, the common man will see the beautiful finish of the concrete and gives him the joy for all seasons. And the last is curing. And in the Saptapadi, it is everlasting friendship and true companionship to each other. So you have given 7 promises to concrete when you start your concrete construction. And these are the 7 steps which you take when you get married also. Only witness here is the holy fire, whereas in the case of concrete, there is God who is witnessing whether you are doing good work or bad work. Successful marriage gives beautiful, healthy children. Successful concrete steps gives you durable structures. So with this, we go to the first step of concrete making, that is batching. Once you select the materials, you have to batch them as per the concrete mix design. In the earlier days, we used to volumetrically batch the concrete aggregates, etc. Nowadays, it is compulsory that if you are doing controlled concrete, you have to weigh batch all the materials. The simple analogy is, if you notice your housewife preparing delicious lunch, dinner, or any sorts of snacks. Each ingredient is checked. Each ingredient is purchased carefully in the market and then proportioned in a correct manner to give you the taste which your taste buds can enjoy. So it is very, very important that when you make concrete, of course, you cannot taste concrete, but at least you will notice the concrete is good or bad while you are taking the 7 steps and thereafter, of course. In batching, many a times people volumetrically batch cement, which is not allowed. If you are doing controlled concrete, the cement must be weighed properly. The aggregates are batched using any type of vessel, like what I'm showing you on the slide is the kadais which are used to make jalebis and sweetmeat in Mumbai is used for batching sand in Kerala. The correct way of volumetric batching is to have these steel boxes, 12 in number, 2 of 45 liters, 2 of 40 liters, 2 of 35 liters, 2 of 30 liters, 2 of 25 liters, and 2 of 20 liters. Because the aggregate grading changes from time to time at the site, you need to increase or decrease the aggregate content. When we use natural sand, we have to take the bulkage of the sand and increase or decrease the proportion of the sand as per the bulkage results. So my guru had taught me, Guru Mr. A.P. Remedios, that it is better to have good steel boxes with long enough handles to handle the weight by 2 workers. And I will now show you the structure of the box. This is a 35-liter box. 2 dimensions do not change. One is the height and one is the length. The width will keep changing depending on the capacity of the box you want. Now in this case, it is, the length will change depending on the capacity. So we have selected 30 by 33.3 by 35 centimeter box, which is having a capacity of 35 liters. If this is 20, the box will, these dimensions do not change. The height as well as the width or breadth or whatever you say. But the length will keep varying. The L will be 20, so you get 20 liters. Like that, you will get the required liters in the content of the box. One has to level the box properly. After taking the bulkage, you work out the requirement of the natural sand, and the firma must be filled completely and properly. This is extremely important. You cannot heat the firma or you cannot put little less quantity in the firma. Otherwise, it will not comply with your concrete mix. design. Now you can hear me. Having time?
Hello, Aishwarya. Hello. Hello.
Okay, thank you. Baro silent થઈ ગયેલા. Accurately measure batching.
Hello. 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 Now you can hear me.
Accurately measured batching of water is extremely important. Sometimes some people have innovated and brought a digital water addition equipment. 5-liter tin is the simple way you can convert an oil tin with a handle, etc., so that every time the mixer operator puts 5 liters. Generally, in the earlier days, when this was not recommended or prescribed, people used to use buckets. And buckets had odd shapes, different capacities, and therefore there would be error in batching the water. At the fag end of his life, Mr. Remedios gathered all the data which he had collected and all the experience which he had collected and wrote a very nice book on concrete mix design. This book is a very useful book and it is available with the Himalaya public. We go further. Way batching in our country was always a problem. The way batchers repeatedly were not handled properly and therefore would get damaged or would become inefficient and therefore had to be calibrated time to time and again. And this was a very big problem when we started batching the aggregates. The man you see here who judges whether the batching is done correctly or not is not an engineer, he's a worker or maybe at the most a mukadam, and he sees whether correct weights of aggregates are put in, correct weight of cement is put into the hopper, etc., and then turns it. But with every bang of the material going onto the hopper, there were chances in those days that the knife edge of the weighing equipment would get damaged and the weighing equipment therefore needed repeated calibrations. Then came the batching mixing plant. Thank God, this really helped us in very accurate weighing and very good quality of mixing. Now, our first experience came somewhere around 1979 when this batching plant was imported from Germany from a company called Liebherr, and our complete idea about concrete manufacturing changed. Nowadays we call it a batching mixing plant or what we call it an RMC plant, etc., with different names but same function. The batching was so accurate that in spite of checking the calibration at every weekend, we found there was no change. the batching plant was functioning, the weighing was functioning very accurate. This batching plant could work on 3 modes. One is the manual mode, where at every instant an ingredient goes in, the operator presses one button at a time. Like for example, if he is pressing for cement, the cement goes into the weighing hopper, then he presses the aggregate, metal 1, metal 2, sand, etc. One after another he has to press. But this batching plant also worked on semi-automatic mode, that is one pressing of a button with the mix fed into the computer will batch 1 cubic meter of concrete at a time. So it was semi-automatic. It also had the operations fully automatic. If you have fed in the computer that you want 5 cubic meters of concrete into the transit mixer below, one after another, the batching plant will batch 1 cubic meter 5 times and give you the complete content of the transit mixer of 5 cubic meters. So that was fully automatic mode. Now, if you notice, the biggest problem is manual operation. Even if you have a computerized plant, and even if the plant is functioning properly, weighing is done properly, etc., the operator, being a human being, can create errors. He may press a button too long and excess material can go into the weighing area, or he may press a button too less and thereby causing less material to go in. So it was always preferred in our experience when this batching plant functioned for the first time on the Tata Electric Unit number 5 project, that it is good for quality, good for strength and durability, good for your statistical data if you run the plant on either semi-automatic or fully automatic mode. Now the question is why our locally made weigh batches were not functioning. They did not have an electromechanical weighing system. They did not have a dust-proof weighing system. As a result, the weighing system needed calibration time and again. Whereas in the modern batching mixing plant, this weighing system very seldom need calibration because they are in a dust-proof environment, as well as they are very, very accurate. The other advantage you get is dispensing of the chemical admixtures. These days, many people use chemical admixtures, especially in the RMC plant. Sometimes they use even 2 admixtures. And they have to be very accurately dispensed into the mixer. And you can see here the dispensing arrangement. There is a small pump which pumps into the dispenser the required quantity of admixture, and the computer will tell the pump how much to add quantity wise, and you get very accurate dispensing. Remember, admixture is the smallest quantity to be added in the concrete mix and has to be very accurately added to get the required effect recommended by the admixture manufacturers. Adding too much admixture or adding too little admixture may not serve the purpose of concrete. Therefore, correct admixture has to be added. I give a very simple analogy that if you are attending a party and taking alcohol, if you are attending and watching your friends enjoying the drinks, if they take too much of it, their verticality becomes horizontal and the slump of concrete also increases, but it falls flat. If they take the admixture or the alcohol in the right content, then they are happy, you are also happy, you see them enjoying the party. If they take a little too less, then maja nahi aata hai. They say, I am not enjoying, I will have to take a little more. So admixture and alcohol, admixture has the same effect on concrete as alcohol on a human being. So dispensing accurately is very, very important. These days, the modern batching mixing plant have also the automatic moisture detection system, which is a probe introduced in the silos containing the aggregates. So as the aggregate goes down on the conveyor belt for weighing, it measures the moisture on the surface of the aggregate and gives an indication to the computer that so much of water has entered along with the aggregate. So the moisture content correction is automatically done and the aggregate gives instruction to the valve over here to release less water or more water depending on the moisture measured by all these three probes and fed into the computer. So this is very, very important. The what I call it as the control of water cement ratio on an easy chair. The computer does the job if you have the measuring systems. But most of the plants in India, I am told that they do not use this type of measuring systems. They have their own versions of it. But in generally, the mixer operator uses his judgment, looking at the mix in the mixer, whether the correct quantity of water is put on. There is another dispensing arrangement or measuring arrangement, Litronic MFG 85 moisture recorder, which is like a plate. So as the aggregate roll out, the gate of the aggregate silo opens. They measure the quantity of water on the surface of the aggregate very accurately within a minute and give the indication to the computer of how much water to add or decrease. As per Mr. Remedios, the definition of CMD, concrete mix design, is a technique of choosing the most economic proportion of available materials. The skill of the engineer will depend on how well he used the available materials. There's no point in getting good aggregate from kilometers away to the batching plant because the transportation will be very high cost. So materials like cement, water, fine and coarse aggregate and admixtures are added to obtain cohesive concrete of the required workability, the specified strength and the desired durability. So this is a very important definition. Now, of course, in high performance concrete, this definition no longer holds good. Mixing is the next step, and for controlled concrete, only machine mix concrete is allowed. The machine can be a 7x12 mixer, a twin shaft mixer, or a pan mixer, or a pan mixer with an agitator, or a transit mixer with twin shaft or single shaft, depending on the owner of the Readymix plant. Generally, we do not have twin shaft transit mixers in our country. This is a 7x12 mixer. You can see young Mr. Remedios supervising the work in one of the PWD sites. This is a twin shaft mixer, and another is a pan mixer. Now, if you notice here, there are paddles on both the sides, so on the shaft. So very efficiently it mixes. These days, most of the Readymix plant have got twin shaft mixers. In the earlier days, we had a pan mixer, which had different angles of blades inside, which can be replaced if they get worn out, etc. The advantage of a pan mixer is on the periphery, it has water spraying arrangement. This is also available in the twin shaft mixers. Spray water as the indication given in the data you feed to the computer. Sometimes 50% of the water is added, sometimes the last portion is added. All depends on what you have fed into the computer. The pan mixer with an agitator is another version which has not yet come into India. This is used for very difficult mixes. Difficult, I mean, is when the aggregate size is very large, or the workability is very low, or the workability is very high, or self-compacting concrete. These are ideal for all these difficult mixing conditions. Now, twin shaft transit mixers have come into vogue, and they are extensively used in Singapore and in Europe, where the distance is short from the plant to the site and efficient mixing is desired. And they have only batching plant with them, not a mixer in the plant. Then this mixer or twin shaft mixer or a pan mixer and quickly mix the concrete while the transporting is being done in the transit mixer. Generally, in a single shaft or in a single fin transit mixer, the fins are all on the periphery of the drum, and it is called a mixer, but it is not a very efficient mixer. We'll deal with it when we come to discussion on the transit mixer. But here you can see the twin fin has the arrangement to spray water uniformly in the transit mixer also, because in a batching plant only materials are put in, the water is added to the transit mixer. Now coming back to our conventional way of mixing, this is a half bag mixer. Though we call it a mixer, it does not mix concrete. See here. I would like to draw your attention to the type of treatment meted out to the mixer. Often the concrete sticks and the worker are recommended. So maro means they'll take a powder and bang, bang, bang on the mixer. Sorry. Till it looks like a face of an old woman with no teeth inside. This mixer will lose its efficiency if it is treated that way. And you can see here the aggregate, the concrete itself segregates at the unloading point only. Even the gamelas are also ill-treated, and you can see all sorts of shapes in the gamelas. What goes wrong in this conventional mixers? The blade of the transit mixer, the blade of this mixer, conventional mixer, this is the original blade. And this is the temporary arrangement done as per the Mr. Remedios' recommendation. We reduce the gap between the blade and the drum. Now this is very important. If you modify this, then you will get reasonably good mix. So the gap between the drum and the blade requires modification. At times it is as high as 6 inches, and this has to be reduced to about 40 mm or less. So reducing by either welding a rod or a flat in the blades. Two blades are there diametrically opposite. So both the blades need to be modified. The mixer drum size is often inadequate. The mixer drum size should have at least 30% empty space for efficient mixing for a one bag concrete mixer. Now what happens is when the mixer drum is not of the correct size, or it is smaller than the recommended size, there is very little airspace inside left in after you put a load of concrete with one bag cement. As a result, the mixing efficiency reduces drastically. It is like trying to eat food with your mouth full. So we tell the children, please chew the food before you swallow it. And same is true in the conditions of the mixer also. If there is no airspace inside or less airspace than 30%, then the mixer will not efficiently mix the concrete. The third important point in this mixers is the baffle plate, which was originally available when Britishers introduced these mixers in India. Now, bafflingly, the baffle plate has gone missing. Now, baffle plate has a very good function in mixing. It scoops up the fine material and puts it on the coarse material below, while the blades pick up the coarse material and puts on the fine material. So alternately you feed coarse, fine, coarse on fine, fine on coarse, and therefore you get a proper mixing. Now if these baffle plates are missing, you'll have to introduce them on the site, and definitely you'll get much superior mixing. Now this photograph is of a Wingate mixer of the yesteryears when British came to India and introduced concrete. The modern mixers, for God knows what reason, have forgotten the baffle plate. Now let's take a look at our pan mixer. The pan mixer, the blades are at different angles. The length of the arms are of different diameters. And within one rotation, it churns up the concrete, which is around 1 cubic meter in the pan. The water is added very uniformly all around by means of a sprays which are installed on the circumference of the mixer, and therefore the mixing efficiency increases like anything. And the mixers are so designed there is enough airspace inside, so mixing is very efficient, and you get 1 cubic meter in a batching mixing plant which produces 6 cubic meters per hour. So 1 cubic meter per minute. 30 seconds for batching and 30 seconds for mixing. So nozzles spread water uniformly, thereby improving the quality and efficiency of the concrete mixer. Now you'll notice that the rotating drum mixer does not have this facility. The water is put at one point by the mixer operator, and therefore the efficiency is less. The mixer has to work for 2 minutes to give you 1 bag load of concrete, 1 bag cement load of concrete, whereas this can give you in half the time 1 cubic meter of concrete. Good cohesiveness is very, very important. And here is Mr. Remedios demonstrating the formation of the laddu, indicating good cohesiveness in the mix. What we call as a ball test. There is no code specifying how to test concrete for cohesiveness. But in the field, we test it this way. We make a nice concrete ball and toss it up about 15 centimeters. The ball lands up back into your hand, and if the shape of the ball looks like this, there is no cohesiveness or there is poor cohesiveness. If the ball comes back intact in your hand, it is good cohesiveness. And if there is over cohesiveness, you'll get slushy concrete back in your hand. So this was how we were taught to measure cohesiveness, and it still holds good. The next test which we perform at the site is generally the workability test using a slump cone, a very old but authentic test. The correct aggregate to cement ratio ensures the required workability, concrete workability, and it is confirmed by a simple slump cone test. The cone is about 300 or exactly 300 millimeter tall, and when you lift it up gradually, the concrete slumps. Then the rod which you use for tamping is put onto the inverted slump cone, and the slump is measured at the top. Now there are always debates whether you measure from the highest point or lowest point or midpoint. We would prefer if you measure it at the midpoint. How the slump cone is filled up is very, very important. It is filled up in 4 layers, and you give 25 blows each using a 16 mm diameter rod with a bullet head or a roundish finish at the bottom, which is used for tamping. So after putting concrete in layers of 4 layers of 25 times, each layer is rodded 25 times, and then with a trowel finished properly, and the slump cone is lifted up and you measure the slump. We take the concrete test of strength by taking only when work trial is successful and should be filled in a manner I'm showing you now. 3 layers, each layer to be banged or compacted 32 times. So 1, 2, 3, 4, 1, 2, 3, 4 like that. You go on compacting the layers one after another. You put the layers and then cast these cubes. The cube looks like this. You can use a 100 cube, sorry, or you can use a 150 cube and fill the cube in a systematic way, rodding the corners, rodding it in the center, and also putting in 3 layers. At the top layer you finish and do some marking on it, indicating for which structural member you have cast that cube. I have seen that taking slump and cube, you need a trained lab technician. The day on which the regular lab technician is absent, you get all different type of results, because if he is not trained, then he can make a mess. Sometimes the cube may fail, but your actual concrete will be good. Sometimes the actual concrete is not good, but the cube gives good results if the technician is not correct. So it's very important to have a standby trained lab technician also at the site. So in case one person is absent, the other person takes charge and does an equally good job. Many a times the cubes are crushed in an erratic manner. The platens between which the cube is crushed are not properly leveled, or they are not planed properly, and you get erratic results. And when you get erratic results, the wrong failure is indicated. If you get correct results, the narrow waist type failure occurs. If both the surfaces of the cube and the platen are very straight, then you get a correct failure. This is very, very important. The next step is transportation. Transporting of concrete should be done as fast as possible without segregation. So if we are transporting manually, you have to make sure that the transportation is done as fast as possible. When you are doing manual transportation, it's very difficult to know the capacity and the speed by which the concrete will be transported, because it will depend on the individual who is carrying the load on his or her head from the mixer to the formwork. Manual transportation using a chain of human beings can be fast or slow depending on the weakest person in the entire chain of workers. Many a times we exploit the labor, in the sense this is the second floor being cast of a 5-star hotel, but the workers are getting minus 5-star treatment. There is a huge flyover made for the worker to climb with the head load on his head, instead of transporting concrete using a winch. So many a times Sorry. Yeah, now it's okay. Now, when you are using equipment, the best equipment and the most well-known equipment is a transit mixer. You can transport concrete in kilometers, horizontally, of course, not vertically. For vertical transportation, you need a concrete pump and a concrete line. Now, these are called mixers, but they are not very good mixers. To mix a load which is batched in a batching plant without a mixer, it may take about 8 minutes for a transit mixer to mix the load. It has got a screw conveyor type of an arrangement. If it rotates in the clockwise direction, it mixes. In the anti-clockwise direction, when the rotation is reversed, it unloads. The blades are like screw conveyors, and the transportation is done. It is recommended that when transportation is done, the drum must rotate at a very low speed of 1 or 2 revolutions per minute, because that will give good agitation as well as mixing. Yeah. The transit mixer works on 3 levers. One is to add water. One is to increase the revolution of the drum mixer. And one is to raise the engine of the truck, should in case you require more power to be given when you are increasing the number of revolutions. The transit mixer has a water tank from where you can add water, should in case you feel that more water is required to be added. But keeping in mind that your water cement ratio does not change than what is recommended for the mix design. This is very, very important. Many countries have banned carrying water in the drum of a transit mixer or in the tank of a transit mixer, because mixer operator is not licensed to add water. You need an engineer to add water. Many a times in Bombay too, they carry either plasticizers in a can. In case it is required, they put that, or they add water. But at the same time, they ensure that the water addition at the plant is a little less, so that should in case you need to adjust for good workability at the site, in case the transit mixer is caught up in the traffic jam or something like that, or is delayed for some other reasons, then it is okay if you add admixture along with water a little bit and revive the mix workability. Now, one thing I must say is that there are a lot of non-compliances reported in ready-mix concrete because of adding sometimes too much of admixtures. Now, when you add too much of admixture, it behaves like chloroform on a human being, and automatically the concrete goes to sleep and does not revive for 6 to 7 days at times, causing a problem at the site. So it is recommended that this addition should be very strictly supervised and not left to the driver and the cleaner of the transit mixer. Otherwise, you can land up into problems. Many a times, the client rejects the concrete because it is not hardened for 6 to 7 days. A simple reason is that they have used excessive chemical admixture, not at the plant. At the plant, everything was batched correctly, but on the site, when the transit mixer arrived, unauthorized persons have added more admixture than necessary. Now, when we debate about the drop in workability, many a times these questions were asked during the workshop, so I have made this slide. Why does the concrete lose its workability? One reason is absorption into aggregates. The aggregates were very bone dry and porous, so they absorbed some of the water which was intended to be used for workability. As a result, the workability dropped, and this causes the drop in workability. Sometimes the temperature of the ingredient is very high because they are brought from hot sun. They are black in color, so they have absorbed heat, and the ambient temperature is higher than what was envisaged, and it caused loss of evaporation during the transit or during the mixing. Hydration of cement, it also depends on the temperature of the ingredients, the temperature of the cement, and the ambient temperature at the time when concrete is being mixed in the transit mixer or agitated in the transit mixer. Now, this problem of absorption into the aggregate can be solved by spraying water on the dry aggregates and let them absorb the water and get saturated so that they don't absorb further water. Mind you, whatever goes into the aggregate will not change your water to cement ratio. This is very important to understand. Only whatever is on the surface of the aggregate, you have to measure the surface moisture content and decide how much water to add or less water to add in the mixer. If the temperature of the ingredients is high and you put water, of course you can't put water on cement and reduce the temperature because cement will harden. But aggregates at least will have the effect of evaporation while the transit mixer is under transit, that the temperature of the aggregates will come down. And that is very good because aggregate is the maximum quantity of materials in the mix. And the temperature needs to be controlled. You cannot help if the ambient temperature goes up or comes down because that is nature. But you can certainly control the water to cement ratio accurately if you consider all these aspects. The next is placing. Placing should be done without segregation, and concrete should be placed as close to its final position to avoid segregation. Manual placing of concrete, one must remember that you do not drop the concrete more than 1.5 meter height. Many a times the workers are workers in the agricultural field and they come to site when the workers are not required in the field. So they have a habit of giving a turn or a rotation to the gamela as if they are spraying fertilizers in the field, and therefore they segregate the concrete. So that should not be allowed. Concrete must be just dumped. like this. And on from the opposite side, your person with a vibrator needle should be there to immediately compact the concrete. Spinning of the gamela is to be avoided. No Mulidharan, no Anil Kumble in the concrete field are required. We need pace bowlers. Just dump the concrete. A glimpse at the equipment development which took place in placing of concrete and transporting of concrete. Early days, the concrete pumps were not pneumatic pumps like which are nowadays. Only pneumatic concrete pumps are available. These were the reciprocating pumps which used to pump concrete in tunnels in the earlier days. Now all sorts of pumps have come in. Very high capacity pneumatic pumps have come in. These were the first pumps which were brought to India from Swing, and that was somewhere in 1979-80. You can see them. Later on, when higher and higher capacity pumps were required for buildings like Kinki building in China or Burj Khalifa in Dubai, very large capacity pumps were bought because they had to pump vertically almost about 600 meters, or in Kinki building they pumped nearly 400 meters. So nowadays pumping is most recommended. Pumping is the only mode of transporting concrete both horizontally and vertically in one go. Of course, if you are transporting concrete from the plant to the site, it has to be in transit mixers, and later on you have to use concrete pumps. Again, mechanization does not mean that concrete segregation will be avoided. If you place carelessly against the reinforcement, you can see here concrete is segregating, the aggregates are flying down, and the mortar is sticking to the bars. And you can see, or you can make out from the coating on the bars that no mortar has gone down, only aggregates have fallen down. And if the filler material is lost, you get voids, you get honeycombs. So placing has to be done well. I will show you how good placing is done even using concrete pumps. Again here, I was photographing the incorrect way of dropping of concrete from a height by the worker, but he's looking at me and he's further segregating his concrete because it is falling on the bars below. Seeing that the worker was photographed, the supervisor pulls the placing boom towards him and further segregates the concrete. So sometimes supervisors are responsible for segregation of mechanized concrete, sometimes the workers. So both need proper training. Seeing that the quality control person was taking photographs, he quickly summons the mason to clean all the shit he has done by segregating the concrete. When you are pumping concrete, is like a big elephant on diarrhea. You can't clean all that mess you make. Once the concrete segregates, the value of the concrete is gone, the filler material is lost, and you get honeycombing, and the concrete will need repairs as soon as the formwork is removed. A simple graph which shows that here is the percentage of voids in concrete and the loss in strength. So 5% drop in concrete. Whatever. 5% voids occurring means 30% loss of strength. So this is a big loss when segregation occurs. So how to do it correctly? You have to have pipe sleeves where you can bunch bars. You can have a funnel type of arrangement for placing concrete. All these precautions. The placer boom should go right in to the lowest reinforcement so that no segregation takes place. Honeycombs can occur if you are careless of placing of concrete. You can see sometimes the honeycombs are so large that often resemble footprints in concrete. This could not have happened. No human being could have gone in, but this is badly placed concrete full of honeycombs. Humorously, you can call it see-through concrete because the cover blocks, the reinforcement steel inside is all visible. The insert plate, everything is visible after the concrete is poured. Yes, we did one unit number 5 PG deck in a very poor manner, and all these photographs are from that. But when we did the next project, we made sure that the bars are properly bunched. There is enough space for the placer boom holes to go right down to the bottommost bars without segregating the concrete. And here you can see not a drop of concrete has fallen on the reinforcement or on the formwork. This is called clean concrete operation without segregation and correct use of mechanization. So when you have a placer boom, then you can place concrete in deep areas. Reinforcement is properly planned, and therefore you get excellent surface finish. This was the subsequent turbo generator foundation which we did for unit number 6. And you can see almost concrete looking like butter, the finish, without honeycombing. And in unit number 5, whatever concrete we did in 24 hours had to be repaired, and the repairs took 2 months. The repairs cost 8 lakhs of rupees when the actual cost of concrete was only 2 lakhs of rupees, 4 times more repairs cost. And in unit number 6, we could place the turbo generator within a couple of days of concreting because concrete had good strength, good finish. And this is what importance of proper supervision does and proper planning does to concrete. This is the first concrete cast using pumps in unit number 5 for columns which were 3 meters long. The contractor wanted to drop concrete from the top, and the end results were obvious. The contractor insisted, no, he has done such concreting in Middle East, and he could not get away with it in Trombay because the concreting came so bad that the managing director of Tata Electric Companies instructed the agency to break all the 3 columns and redo them. So segregation of concrete in densely dense concrete dropping from the top is observed. So one has to do concrete in a careful manner. We had specifications which said that the concrete should be done 14-meter high column in one go for unit number 6. So we planned the reinforcement, we planned the lowering of the placing boom and an elephant trunk which goes right down so that no segregation takes place. And you can see densely reinforced columns, well constructed with good finish. Super height pumping is done in 3 manners, either injecting through holes. First you place concrete and then you inject the mortar through holes and grout sort of concrete. This was the earlier days technique. High dropping of concrete from the top, which is not recommended. And the Chinese have developed jacking of concrete. They push the concrete from the bottom. The advantage of dropping, this is easy operation, but segregation needs to be taken care by lowering the hose pipe right down the throat of your form. The other is pumping. You pump the concrete upwards. Now this has a full advantage, no filling, good filling, easy pouring, and no chance of segregation. The shortcoming is that you need high pumping pressures, and it is a tedious operation because every time the pump stops, the concrete comes back into the pump. So you will have to use a hydraulic valve at the commencement of your pumping, so that every time the valve is shut, then the pumping operation starts and again open. So it is something like a non-return valve which you have to put in concrete. Concreting has to be done in a correct manner. The transit mixers should be able to approach the pump from both the sides, so that should in case one side gets redundant due to waterlogging or whatever problems are there, or the transit mixer himself has broken down and cannot be moved away, the pump can be approached from the other side. A standby arrangement is almost mandatory when you do large concrete pours. This is very, very important. In Tashkent, where we constructed the 5-star hotel building and the raft was being built, we devised the arrangement in such a manner that the transit mixer would be stationary and not move. The batching plant would unload the concrete into the transit mixer, and whenever the pump operator needs it, he operates the pump and the transit mixer simultaneously and transports the concrete through the pump. Now there we had an advantage was the batching plant was located just across the road, so we used to block the road with the help of the police, local police, and pump the concrete to the other side where the raft was being concreted. Placing the transit mixer below the batching plant, which was not done in unit number 5 and 6, increased the speed of concreting. We could go up to an average of 45 cubic meters per hour when all our equipment was geared up for 60 cubic meters. But in Trombay Thermal Power Station, we could only achieve the maximum of 35 cubic meters per hour. So this gave us an advantage of faster work. It's okay. There are our luxury. Here you can see the batching plant. From the batching plant, the pipe comes and places concrete. This is a swivel joint which is used for placing concrete in rafts, in slabs, etc. Very seldom this swivel joint is used, but we had procured it and used it in Unit 5, Unit 6, as well as in Tashkent. This pipeline was about 300 meters long from the batching plant to the site. After we did a lot of concreting in Unit 5, around a lakh of cubic meters of concrete, we realized that we need a concrete placing boom. So we had to purchase a concrete placing boom. The earlier days, the concrete placing boom did not have steel bends, but they had rubber hose bends, and they were not very efficient. Frictional resistance was much more. But later on, many European companies came about with brands like Putzmeisers, Schwing, etc., Elba. They came about with steel bends. The largest boom for some time was 62.5 meters with a 125 mm dia pipe. But later on, a mammoth truck-mounted placer boom came into being, 70 meters long, and the entire unit was on 10 axle trucks. This unit was on 6 axle trucks. Now, the important point is this particular invention came in the way of technology of roadways. In Germany, the autobahns, there is no speed limit. You can travel as fast as you can. Where a Mercedes Benz may be traveling at 300 kilometers per hour, this huge dinosaur type equipment adjacent to it started creating safety problems for the cars. And hence, they were not used in Germany anymore. The two equipments which were produced in Germany, one was sent to Saudi Arabia and the other one went to Greece in Europe, where the rules were less stringent and the speed limits were specified for the cars in the adjoining road. So it is very, very important to plan things. However, I was surprised that again in Germany they started using a bigger version of the truck-mounted placer boom unit. Next comes is compaction. Concrete using a 50 mm diameter needle, 60 mm diameter needle with a slump of 50 mm is adequate. For narrow sections, you need smaller needles and higher slump. For tremi concrete, you need almost 150 mm slump, very high flowing concrete is required. And today for foundations and large rafts, we use self-compacting concrete, which is almost flowing concrete and not specified by slump. It is specified by concrete flow. We can test the flow by inserting a needle. This is the Remedio style of measuring the flow of concrete using a needle vibrator, but there is no standard for it. There are now standards available when you test flow of concrete with different types of testing devices, I think one lecture needs to be planned for testing of self-compacting concrete also in future. Reinforcement should be planned in such a manner that there is enough gap between the bars and enough gap between the formwork and the reinforcement cage so that the needle goes down properly to the correct location. Now, many a times the needle may hit the bars or the formwork if there is restriction in the area where the needle is to be taken down, and that causes damages the needle. Needle should never be held at the beginning of the or at the junction between the hard portion of the needle and the flexible portion of the device. If you hold the needle very close, the needle stops operating after some time. The needle is safely held 2 feet above the hard portion. Then the needle functions safely. But it should not touch the bars. It's very, very important. How to handle the hose and how to handle the needle vibrator, the operator needs to be trained. And if now it will be. The correct and incorrect method, you can see here, this is the incorrect method. If you start dumping concrete from both the sides and vibrate, there will be no air escape. And that will result in honeycomb or big voids and poor compacted concrete below. Whereas if concrete is placed from one side of the void former till it emerges out at the other side, and then you do the placing here and vibrate the concrete will come well compacted and there will be no voids. You can see we wanted a void here, but we got a void here also. So void below the void former because there was no air escape. So this was the mistake we made in Unit 5 DG. Later on, the shape of the beam in the TG deck was changed in Unit 6. It was made rectangular. So this type of void formers were not required. When you are supervising concrete compaction, the human being should be able to go, and if it's a very large foundation, he can go inside and see where the concrete flows below the bars. It is very, very important that the person who is handling the needle vibrator and person who is supervising actually observes the flow of concrete below the bars so that later on no corrosion can occur in the foundation. This is very important, but make sure that the persons come out of the concrete when you are finishing the concrete. We don't want too many anarchalis in our concrete. Finishing is very necessary and concrete must be finished to proper line and level. Now, many times while finishing, we have noticed that sometimes over vibration of the concrete on the surface takes place, which is bad. Because if the aggregates are missing, the concrete at the surface starts cracking faster. So we have to have a panja-like thing. So you rake up the aggregates and then trowel the concrete on the surface. So raking of the coarse aggregate, bringing them again on the surface and then troweling is a better practice and avoids surface cracking on the top. You can see here, these are the concrete roads. In the earlier days, they were not having paving equipment here. When concrete roads were introduced in Mumbai, they had to be leveled manually. And of course, you can see here that attention is again to the photographer and not on concrete. And that is a wrong practice. They used to use a beam vibrator and vibrate the concrete on the surface. But this was a non-reinforced concrete, but still needed compaction because it was not very highly workable. They were having stiffer mix. Again, it all depends on the specification. But slip form pavers were introduced very soon in Mumbai-Pune expressway, where pavers, very costly of course, were fed with a very low slump mix, 20 to 30 ml mix. Pump needs more workable mixes. It is always important to know that you give the correct mix to a correct equipment. If you give wrong mix, whatever mix is used for pumps to a paver, it will not work properly or it will not work at all. Similarly, a stiffer mix, if you feed to the concrete pump, it will not work, it will not function. So here you can give lower workability mix which can be transported even in dumpers and unloaded. These pavers were used on the expressway in high ambient temperatures, so they have put a cover over the equipment. But actually the cover is more required over the concrete which is freshly placed. But here the human beings also needed shelter, so they have put on the equipment. And this is how the paving equipment rolls. Troweling was done on a very stiff mix but well vibrated mix. Sometimes the worker had to stand on the trowel to force or the weight to give proper line and level to the road. A gang of workers followed. They used to spray the curing compound as well as do some small measures of repairs in case the mix has not come out properly. The touch-up was required and curing immediately was necessary. My own experience showed that when I just after the expressway was completed, I traveled from Mumbai to Pune, and I felt that on a well-traveled, well-finished road, you get a feeling that you are flying in the air. You can go to higher speeds, even though 80 kilometers was the maximum speed recommended. Some cars I noticed were going at 150 kilometers per hour because we were traveling at 80 and zoom, the cars used to overtake us. But very soon some problems have developed, cracking and other problems. So repairs were necessary. Proper curing hardens the surface and reduces the cracking and improves durability. So now let's look at what creates problem. Concrete is like an egg, it cracks. So what is not cured properly has to be endured, because this crack will soon develop like a pothole. Horizontal curing is done, but the road is cambered, so you will get spots of dry surfaces. So you must make sure and ensure that the highest portion that is in the center of the road is also cured by wet curing and ponding if required. I had dealt plastic shrinkage in the earlier lectures on basics of curing, basics of cracking. Plastic shrinkage cracks appears within 30 to 360 minutes. But I have seen in hot weather, it appears even within 10 minutes. It appears in thin walls and on slabs. In slabs, because the surface is fully exposed, it appears very fast. When the evaporation rate exceeds 1 kg per meter square per hour, plastic shrinkage cracks are expected to occur, and they do occur, and they occur almost in all parts of our country, from Kanyakumari to Srinagar, because of hot ambient temperatures, because of low humidity, or because of high winds. These are the three enemies of concrete when it is born. The secondary causes could be reinforcement near the top, low rate of bleeding. If the concrete bleeds faster, it gives a thin sheen of water on the surface, and therefore less chances of plastic shrinkage crack occurring. Now the preventive measures are improve early curing, which I will deal with in a little detail in the next slide. Use cohesive mix, avoid gap graded aggregates and cement. Even cement has to be uniformly graded. When evaporation rate is below 0.5 kg per centimeter square per hour, plastic shrinkage cracks are not expected. So when it is a matter between 1 to 0.5. Now when plastic shrinkage cracks occur, the most effective solution is cover the concrete which is freshly placed immediately with a plastic sheet. Don't worry if the plastic sheet creates a little surface roughness, because ultimately you are going to do waterproofing and sort of plastering or sometimes tiling the slab. So this is very, very important. Vertical concrete surfaces properly, but not in this way, like a poor lady's sari, all torn and tattered. It has to be done in a very systematic way. This is Kerala style automatic curing, which I observed. A dabba is put, hopefully with water, most of the time without water, and they expect drops to fall on the freshly cast concrete, drop by drop, and that is what they call curing, especially when water is available in plenty. So the concrete must be saying water, water everywhere, but not a drop to break. Long-term drying shrinkage can also occur if you had not done your concrete curing religiously after its casting for 7 days, or sometimes recommended even more. In thin slabs, yeah, my computer seems to be in slight hurry. Thin slabs and walls, due to inefficient joints, you have to cut the concrete so that concrete beyond a certain time length will not shrink. It will be a separate joint. Moisture differential between the top and the bottom surface. Now, When we were in college, we were told that the concrete should adhere to the lower concrete, the lean concrete which you put, the structural concrete on the top. But no, now the whole concept has changed. The moisture differential between the top and the bottom surface of the slab or between the two surfaces of the wall may occur, and the concrete might sort of take a saucer type shape because the top surface will be shrinking more than the bottom surface because the top surface is exposed to sun, etc. So nowadays we do not specify proper mechanical joint between the base of the slab and the top and the pavement concrete on the top. So we put either a sisal craft paper or a plastic sheet and then put the pavement concrete over it. The secondary causes could be excessive shrinkage, inadequate distribution steel, or use of rich mixes. The preventive measures are reduce water content and cement content so that shrinkage reduces. But the most important is you have to cure the concrete. Increase the distribution steel. Protection of concrete against rapid changes in temperature and surface moisture loss. If you can put the plastic sheet for 7 days, excellent. If you can put for a longer period, still better. Curing for extended period sometimes is recommended when you are using blended materials like slag and fly ash or blended cements. Curing for extended period for 28 days that the roads are not being cleared for traffic resulted in reducing the curing period to 14 days. So sometimes political pressure can cause pressure to the technical people and ultimately leave the concrete with a lower grade. Reduce, restrain with the base and sub-base. Like I said, put a sisal craft paper or a plastic sheet between the base concrete and the pavement concrete. You can see here inefficient. The engineer thought that there is a manhole in between, so he won't be able to cut a groove here. But concrete thought that there's a longer length, so it made its own crack because the engineer failed to give a correct groove at a correct spot. Concrete shrinks equally in all directions. Please make a note of that. So you can't have rectangular groove pattern. For example, this length is long here, this length is short, so the concrete cracked in between. Here you can see a close-up view all along where the length was more, the concrete cracked in between due to grooving of the concrete or joints in the concrete. Well, friends, I covered my lecture and I really thank some of the slides to me by Mr. A.P. Daniels, who is no more with us in this world. And if you want more details, you can refer to the Ambuja cement booklets, which are available with them. And some of them are available with me. So if you don't get them with Ambuja cement, you can either send emailed to me or personally collected from my residence. Thank you very much for your patient hearing. Of course, you have no choice because I am giving a webinar. I thank my wife and participants for your presence and good wishes. If there are any, you can forward the questions to Shelly on his email, which is given here. I thank the organizers and also the managing director, Shelly Fernandez, and his team, Kausika and Ashwarya, for making this possible for me to do this webinar. Thank you very much.
Good afternoon.
Good afternoon.
We appreciate your valuable time, and we are thankful to all the audience. We QCrete are fortunate to have Mr. Dodi sir doing our webinar. As usual, Mr. Dodi sir has touched all important aspects which need to be taken care during different stages of concreting. And I must say here that in my life, I have not seen any better person explaining different aspects of concrete patiently and beautifully, like Mr. Dodi sir. We are thankful to you, sir. Thank you again. Thank you, sir.
Thank you. Thank you.
Yeah. Yeah. Any questions can be forwarded to Mr. Shelly Fernandez, our MD, as given here. And you can also visit our website. Thank you. Thanks.
Okay.
Thank you. Thank you.